This lesson is on dividing with scientific notation. Up until this point, we know how to write numbers in scientific notation, we know how to add them, we know how to subtract them, we know how to multiply them, and now we're going to learn how to divide them. Looking at the first example, we have 6.5 times 10 to the sixth divided by 7.3 times 10 to the second. We could write this out in standard form and divide it, but again, that would make it much more difficult than it needs to be. So if you can remember back to fractions, because division is a fraction bar, if you have 2 times 3 and you're dividing it by 6 times 10, if you remember, you can simplify first before you divide. So I can take the 2 and the 10 and I can both divide those by 2. 2 goes in the 2 once, 2 goes in the 10 5. The 6 and the 3 are both divisible by 3. So 3 goes into 3 once, 3 goes into 6 twice. And now I have 1 times 1 as my numerator, which is 1, and 2 times 5, which is 10, as my denominator. Now, if you're not sure, you don't believe me that that would work, go back and prove that this answer is 1/10. So if I go back and I undo everything I've done, not everything I've done, if I go back and multiply straight across, I get 2 times 3 is 6, and 6 times 10 is 60, and that reduces to 1/10, which is what we originally had. Remembering that, you can divide, you can simplify using the fraction bar. So we are going to write this problem as a fraction. So using a fraction bar, we're going to write 6.5 times 10 to the 6th. That's our numerator because that's what's being divided by. So we're going to use a fraction bar for division, and we're going to put 7.3 times 10 to the second below that. Now, remembering what we just learned, we learned that we do not have to multiply first to simplify. We can simplify before we multiply. So let's simplify what we know. The easiest thing to do with simplifying would be to take 6.5 and divide it by 7.3, just as if you were going to take 6 and divide it 6 halves and simplify it. So when I take 6.5 and I divide it by 7.3, I get a rather large number, 0.89041096. Now, depending on the directions, you may be able to round that, but make sure you read the directions. If not, keep it as is. Then I'm going to divide 10 to the 6th divided by 10 to the 2nd. We know how to divide exponents because we learned that, and that's subtracting them. So your base stays the same. So I have times 10, and then 6 minus 2 gives me 4. Now, as always, before you get excited and think that you're done, look at your problem and ask yourself, is this in scientific notation? If I look at it, the number that's in front of the decimal point is 0, and it needs to be between 0 and 10. It cannot equal 0. So I must move the decimal point over one spot. When I move the decimal over to the right, remember you are subtracting 1. So now my answer is 8.9041 times 10 to the third. Let's look at the next problem. I have 7.9 times 10 to the fifth divided by 2.3 times 10 to the third. Break it apart into problems. Do the numbers first. And if you take 7.9 divided by 2.3, you get 3.43478261. Now take your exponents, 10 to the fifth divided by 10 to the second, or I'm sorry, 10 to the third, which would equal 10 to the second. So I have times 10 to the second. Check to make sure that your answer is in scientific notation by looking at the first digit. The first digit in front of the decimal point is 3. That is between 0 and 10. So that's my answer. Let's look at the next one. 4.8 times 10 to the fourth divided by 2.95 times 10 to the sixth. If I divide those numbers, 4.8 divided by 2.95, I get 1.62711,864. Now divide your exponents. So 10 to the fourth divided by 10 to the sixth. You subtract them. 4 minus 6 is 10 to the negative 2. Now, when we were simplifying exponents, you were not allowed to have a negative exponent. But remember, we are doing numbers in scientific notation, and you are allowed to have a negative exponent in scientific notation. It means you would move the decimal point 2 places to the left if you were turning it into standard form. Again, look at that first digit. The number in front of the decimal point, is it between 0 and 10? And it is. 1 is between 0 and 10, so it's a correct answer. I can leave it as is. Now, let's try and evaluate without using a calculator. So looking at these numbers, I am going to first take 8 divided by 5. Now, before you panic, it's going to take a little work, but you can do it. So 8 goes in the house, 5 goes on the outside, 5 goes into 8 one time, and you get 5. Subtract, you get 3. Add a decimal point and a 0, bring it down, and you get 1.6. Now do your exponents. Times 10, 10 to the third, minus 10 to the fifth. Be careful. Watch your negatives. So when I subtract, I have negative 3 minus negative 5. That means I'm going to add the opposite. So negative 3 minus a negative 5 is a positive 2. Always check to make sure your number is in scientific notation. Looking at the number in front of the decimal point, it is between 0 and 10. So there's my answer. Let's look at the next problem. 1.4 divided by 3.5. Now you have to remember how to divide decimals because you cannot use a calculator on this. So 1.4 goes in the house, 3.5 goes on the outside. You can't take a decimal into a decimal. You have to move it. So move the decimal point over one spot on the outside. You move it over one spot on the inside. So now I'm taking 35 into 14. I cannot take 35 into 14, so I have the decimal point and the 0. Decimal point goes above the house. Now, can I take 35 into 140? Yes. Well, how many times? Well, start guessing. 35 times 1 is 35. 35 times 2 is 70. Hey, I know that 7 goes into 14 twice, so let's try 4. 4 times 5 is 20. Carry the 2. 3 times 4 is 12, plus 2 is 14. Subtract and you get 0. There's your answer, 0.4. Now take your exponents. 10 to the 4th divided by 10 to the negative 4th. Remember, you are subtracting your exponents. So negative 1 minus a negative 4 gives you negative 1 plus 4, which is 3. So 0.4 times 10 to the 3rd. Always check your answer. Look at the number in front of the decimal point. Is it between 0 and 10? No, it's not. So I need to move my decimal point over one spot. When I move it over to the right, I subtract 1 from the exponent. So I'm left with 4 times 10 to the 2nd power. And that is my